Good afternoon, everyone. Thank you all for joining in today's webinar. My name is Devanshi Mehta, and by way of introduction, I manage the outreach programs at NASCOM Engineering R&D. Topic for today's session is designing a scalable EE architecture that meets the future customer demands. We have Kishore LM and Nagahari Kiran Tirupati from BlueBinaries to cover the topic. Before we begin with the session, I would like to give a quick introduction for the session topic and the speakers. Currently, the automotive industry is facing a multitude of technology-driven disruptions. Software is becoming progressively more important as it increasingly determines the value of a car. In other words, the digital car is finally arriving with over-the-air updates, replacing auto shop visits, etc. A well-planned holistic approach to electrical and electronic architectures will increase vehicle safety, security, and system usability while also reducing cost to the manufacturer. Architecture decisions made now will be a vital part of meeting the autonomous, connected, and mobility expectations of a consumer 5 years from now. In this webinar, look forward to learn how to orient the design of an architecture keeping in view the multi-year development time, its life cycle, and customer expectation. To talk about the topic, we have Kishore and Harikiran. Kishore LM is an industry expert with more than 2 decades of experience in vehicle EE architecture design, integration, and testing, with exposure to both OEMs and system supplier environments. His passion to create the difference in auto industry has made him pursue entrepreneurship with BlueBinaries. At BlueBinaries, he leads the engineering team to deliver safe, reliable, and efficient solutions with agility. Prior to this, he spent almost 20 years with an Asian OEM and German system supplier building high-performance teams and capabilities. He possesses this rich experience due to his involvement in developing EE architecture for 4 new vehicle platforms and 50+ vehicle launches. We also have Harikiran with us. In his current role at BlueBinaries, Harikiran leads the EE architecture practice and defining solutions along with his team. He also drives the consulting practice to global customers in designing safe and secure architectures for future mobility requirements. Prior to this, he has worked with global customer programs in designing state-of-the-art EE architectures with high reusability and scalability. He has extensive experience in exploiting AUTOSAR standard to its core and expertise on emerging technologies like Ethernet, DOIP, SUMIP, and SecOC. It is great to have you, Kishore and Harikiran, as our speakers today. As a small note to the audience, I would like to inform you that you may put the questions in the questions panel of the GoToWebinar console towards the end of this session. And before we begin with the knowledge session, our speakers would like to have a quick poll of the audience and understand. So, dear attendees, I am launching the poll on your screens now and request you to kindly choose one particular option for our speakers. You have 30 seconds to answer this poll. 15 seconds more to go. Okay, thank you. I am closing the poll and sharing the results on your screens now. 17% are novice, 40% are beginners, 23% are intermediate, 17% are advanced, 4% are expert levels in this webinar present. Thank you attendees for sharing the options. And now I request Kishore for his presentation.
Thank you, Devanshi, for the nice introduction about BlueBinaries and me and my teammate. Thank you all for joining this session. I hope it would be a more of an interactive session where we thought we would like to share our experience in this area, which is actually helping some of the industry stakeholders design the architectures for the future and try to see how consumers benefit uh, with this new technologies and the methods that is enabling the consumers benefit from the technologies that are emerging. So the contents of the slides are categorized as predominantly into three sections. One is the future mobility and architecture trends. Post that, my colleague would explain you in detail the design methodology, talking about the service-oriented architecture method and how it influences the design, and also we'll speak about the improved security requirement that is needed, since it's more of a connected concept, and hence that is also vital, and that is the reason we would also brief you a little bit about it. And then a summary and conclusion. There are some backup slides. If time permits, we would touch upon that. Otherwise, these are the major contents. In a nutshell, the automotive industry is no more an automotive industry. It's basically a mobility industry. Large part of the industry has recognized it and have in turn made automotive or their products as mobility services rather than vehicles. What takes the mobility forward is, in a nutshell, I categorized this into 5 areas. One is the maturing powertrain, or the powertrain technologies, starting with the immediate electrification of the vehicles. Of course, offering higher energy efficiency than what it is today, lowering the emissions to an extent, and also providing diversity to the energy that is available. There are new trends, of course. Commercialization is a bit far. I haven't touched upon that, like fuel cell, for example, hydrogen, for example. These are technologies yet to evolve and get commercialized. For now, the industry sees electrification as the next major change in the way powertrains are going to change from the current trends. That is one trend that we see. The second advancement is the connectivity. Connectivity in different ways. Connectivity with respect to data, what you see in the vehicle to the user. Connectivity with respect to the living and connected to the product or the vehicle. But the major part is the concierge services, where today the consumer most wanted connected feature is the way he started using connectivity as a service in terms of utilizing the vehicle and its capabilities, as well as the product along with the ecosystem. That's where V2I and V2V and other communication technologies like 5G or LTE is getting integrated very much into the products. The other one is the autonomous, or the emergence of autonomous, starting from a simple driver assistance functionality to fully autonomous driving, not just for conventional use, but in multitude ways of usage of this technology with connectivity also playing a role here. That is something that we see as one trend. The other one is the shift in mobility preferences. No more vehicle is perceived as a want, or it's more used as a service. Like what we see today is 50% of Gen Y consumers simply use uh, up their smartphone apps to have transportation as a service, or mobility as a service, uh, starting with simple functionality or simple use case like carpooling or sharing. Beyond that, there is so many use cases to that. For example, integrated mobility, like metros with carpooling applications, etc. These are some things that is evolving, or have evolved in some areas of the world, and still evolving in India. Last one is quite important too. Lightweight technologies, like aluminum or alloys, carbon fiber coming into the particularly these are the technologies today is being used in high speed or high powered vehicles, but we see that to coming into conventional or mass mobility products too very soon. I would say they are already being applied partially. The extent would only go up. These are the trends that we see, majorly that is disrupting the mobility industry. Of course, the trends pose quite a significant amount of challenges, uh, which are not new to all of us. Uh, uh, the challenges include the pace at which the technologies have to be integrated, and brought to the use of the consumer. That's something, the pace at which the innovation has to change, and it has changed, but still lot more is expected by the end consumer. Uh, the technology integration itself, taking example of AI or ML integration into the products, if you want, or autonomous driving, for example, brings in terabytes of data to be sliced and evaluated before the decision by the supercomputers that's getting integrated into the cars take decisions. These are these are some technologies and the ways that has to be integrated into the uh, products is something challenging. Personalization, different consumers, different cultures, different parts of the world has different choices and tastes of their own. That is something that customers and OEMs think through a lot before a product is conceived, uh, with a lot of personalization taking place right at the beginning of the product or the architecture definition. Upgrade without major changes as the product gets used is something that is perceived as a want, and but that poses not just simple challenges, but severity in terms of security, for example, or the amount of content that has to be validated before it is pushed into the product as an upgrade. Not, but the least cost pressures, something is always in need or want from the end consumer. Uh, More functionality at a reduced uh, price or reduced cost is something that poses a challenge when to integrate particularly new technologies and more functionality. That is something, it's quite an issue. Last one is the brand switching. Consumer switches brands quite often. How to retain them is one thing that OEMs uh, do lot of uh, do take a lot of pride in and put in their efforts to retain the customer and maintain or getting the loyalty or benefit from the loyalty. That is something that also plays a role. These are quite some challenges. There are beyond these challenges, but from the trends uh, that is driving the industry today, we just wanted to touch upon few of them, which are relevant to the product engineering and the design of an architecture, and hence we brought in this. Um, what we feel to address this is to take down a top-down approach and solve some of these issues. Thereby, uh, the architecture uh, plays a very vital role and becomes the backbone to the product to bring in the pace at which the innovation has to be put in place or bring in new technologies and new functionality, something rather than bottom up in technical words, rather than ECU to the architecture, architecture to the product to the architecture, and architecture to the functionality is what we believe that it can solve some of the challenges and hence become a very critical piece to the product development and its evolution. That is something that we would touch upon in this session with you all. Devanshi, there is a poll. Can you put in the poll before we move to the next part of the presentation, where Hari would take in?
Yes, sure. So attendees, I am launching another poll on your screens. Request you to please put out your options. The poll reads as: suggest the challenge you are currently facing in the architecture design. You have 30 seconds to answer this once again. It has 4 options: reduce the traffic of signals, cost effective, reliable and easy maintenance, and none of the above. 10 seconds more to go. Okay, so I am sharing the results now on the screens. 9% say reduce the traffic of signals, 35% says cost effective, 47% believe in reliable and easy maintenance, and 9% say none of the above. Thank you, and we shall again hand over to the speakers.
Yeah, thanks, Devanshi. Yeah, I I'm passing the presentation to my colleague.
Um, Hari,
Oh,
I have shared it with you.
seems to.
Can you hear us?
Uh, I think yes, there is a connectivity issue. We just wait for 5 seconds and see if we can come online.
Sure. Kishore, any update? Like,
Gone away from the conference. He's logging in back. He just
oh,
passed on MSA.
so is it possible if we launch one more poll for the audience and gain their opinions?
Yeah,
Meanwhile,
sure. I think. Yeah.
yeah. So, audience, we have one more poll on the way, and I request you to choose an option for it too. Meanwhile, I guess Hari should be able to join. So, this requests you to answer which advanced feature do you believe is the most valuable for mobility services. There are 5 options here, and 30 seconds again. All right, thank you. And I'm sharing the results on the screens. 22% believe connected living is more valuable, 40% autonomous vehicles, 9% shared mobility, 2% pay how you drive, and 27% energy management. All right, I hope this is valuable to our speakers as well. Thank you for giving your opinions on the polls.
Yeah.
And Kishore, meanwhile, oh yeah, we can see
Yeah.
Hari on online. Hi, Hari. Is
Hi,
it okay?
sorry.
Yeah,
Yeah. Sorry for this.
no issues. I am sharing the rights with you. Please do continue with the presentation. Our attendees are online.
Okay. Um, Let me know if you can see my screen.
Yes, we are able to.
Okay. First of all, sorry for the technical glitch, and thanks Devanshi and Kishore for the introduction and setting the context. Let's move on. We all we all know after decades of car manufacturing, the digital car is now become a reality, and we are all seeing that in the latest trends of automotive in auto shows and next coming car launches, concept cars, where automotive industry is moving towards the digital car. And same time, the automotive is slowly moving from a phase where it is predominantly driven by a hardware in terms of stronger engines, sleeker transmissions, and smooth suspension, which was once upon a time a point of discussion or a point of decision making for choosing a car, is now slowly moved towards a feature base where we are talking about features in a car rather than the hardware part, which which is and software has become an enabler of these transitions. So because of the huge amount of software getting introduced in the car, we are now slowly started talking about uh, features rather than the hardware in a car. And today's software is driving most of the key automotive breathtaking path breaking technologies in the car, be it autonomous driving, connectivity, electrification, smart mobility. All this became reality and differentiator after introducing the software into the car. As a result of this, automotive industry is now facing challenge inside and outside, be it from the feature number of features to be implemented in the car, from the expectation of the market to how do they satisfy the requirements of the market with the amount of the software that is getting introduced in the car. Uh, and the software from building from a, and this and also they have a challenge now with how do they manage the increasing demand of new functionalities with the existing EE architecture. How can the architecture can be smoothly transformed from the existing architecture to the more complex of architecture which can handle more complex functionalities with increasing in the demand. Okay, so in my next coming slides, I would talk about the evolution of architecture, how architecture has evolved, and what is making architecture also evolve, and what is the risks that is coming due to the evolution of the architectures. Okay, uh, Devanshi, I think we have a poll now. It's
Um, Hari, actually, while you were joining, we did a poll.
Mhm.
I will share the results with you.
Okay, that's fine.
Eh,
Then
yeah. Okay.
yeah, we'll continue. That's fine.
Sure.
Okay, if you see these the evolution of architecture and future trends, uh, how architecture has been evolved over the last 2 decades, and how is it going to transform in next 5 years, and beyond that, how it is going to be there. So I'll talk about this in my next slides. So in the very beginning, where when the electronics is newly introduced into automotive, where the automotive moved from more of uh, uh, a mechanical driven to a software or an electronics driven. uh, Initially the architectures used to have very few ECUs, and most of the time these ECUs are isolated from other ECUs, where each ECU is managing a specific functionality, and it hardly speaks with the other ECU on the car. Later, then due to the introduction of different protocols in the automotive like CAN, LIN, uh, slowly the trends has been changed from an isolated ECUs to a connected ECUs, where ECUs get connected to other ECUs on the network, collaborate, and exchange data. With this, they can build more functionalities in the car, and bring up a collaboration within the domain. So later there was a domain based ECUs, where you have ECUs for a specific domain like body, chassis, and powertrain, which would enable the automotive companies to have a more flexible architectures among their distributed networks. So you have a distributed network, you have a network for body, you have a network for chassis, you have a network for powertrain, where all the ECUs in that network talk among themselves, and then if required they exchange the information between the other domains. But that was limited earlier. The exchange between the domains was, the amount of information was very limited earlier. Then slowly we now started adapting a system called adapting a process where you have a centralized gateway which acts as a master of all these ECUs, and thereby establish a sort of a communication between domains. So one domain can talk to another domain via these central gateways. And currently most of the all automotive companies have reached this stage of architecture, where everyone started successfully implementing the central gateway based architectures, and they were able to deploy and see the results of this. So this is where we are currently now, with the central gateway, one central gateway being acting as a backbone, and establishing the communication between different domains and the ECUs connected to the domains. Let's move on to the future. How? So what we are foreseeing now with the trends in the automotive, that the next 5 years, the automotive architectures would move from these central gateway based architecture to a domain based architectures, where you have domain controllers which would act as a master of that domain, which would take most of the functionalities, control mechanisms of that domain at the domain controller level, and then distribute only a required information or cross domain functionalities among the other domain controllers. And then the central gateway itself is becoming a domain controller now. So this is the trends that we are seeing. With this, we can introduce highly complex functionality into the cars, where each domain controller is now capable of handling most of the functionalities of the domain. And then with this, the cost of overall implementation or the cost of optimization will significantly reduce, because the domain controller itself is now able to handle most of the functionalities within that domain and manage the ECUs connected to the networks under that domain controller. And for these to handle, Ethernet is now slowly becoming the backbone. So Ethernet is acting as a major communication protocol, where it takes majority of bus load, overall the network load, and in this way it will helps the domain controllers to operate faster, because Ethernet sends and receives data at much faster rate than the CAN or LIN, and the domain controllers can quickly make decisions and become super fast. And this is the future which we anticipate that the automotive will be slowly moving into that, where instead of dedicated ECUs, you will have everywhere a domain controllers, a domain control units, which will handle most of the functionalities there, and then hardly distribute very limited and critical information across them via Ethernet. We are also seeing the trend that the Ethernet would be the future. Ethernet would be the would take majority of network load, and you will hardly see a CAN or LIN in the future. With this, it will become more agile. So the development of complete EE architecture, which become agile, where you can have an incremental introduction of functionalities in the car, because each domain controller would be handling their respective functionalities, and there is hardly a dependency on the other domain controller. You can also handle highly complex and complex functionalities and functions. Uh, Very limited dedicated hardware, where the hardware can be also shared, where will be very limited chances of having a specific hardware for each domain controller. So the domain controllers would be the software in the domain controllers would become more independent and hardware independent. And then we are also seeing that there could be virtual domains, where you can host some functionalities of your vehicle on a cloud, where you have a virtual controller on the cloud, and your car or the uh, will continue interacting with the cloud and exchange information during the runtime. So with this, as you've seen the trends that is happening in the automotive, and Ethernet as becoming more critical and a backbone of the architecture. Uh, we are also entering into an era where we will be handling most complex functionalities, more signals on the channels, and how this will be handled in the future. Let's see. So we have seen the challenges, the majority of challenges this automotive industry is facing. We have also seen the trends from where the architecture is moving, and then now we will see the solution, where how do we address the complexity of the Ethernet, the number of signals on Ethernet. So I will not be talking on all the solutions available. What I have chosen for this webinar is how service-oriented architecture will enable the to handle the complexity. Okay. So service-oriented architecture, which is mostly um, spoken as a SOA in the automotive industry. So the SOA is as a top-down design approach where the information is communicated between participants, where you have a provider and consumer as a service packet. So this is more of a service based communication where you request a service and you get a response for a service, and the service is itself is a discrete unit of functionality which can be accessed remotely and changed and updated independently. So each service can be a functionality as such, and you can access that functionality from anywhere within the vehicle. You can also change or update the service independently of the provider. Okay, with this also represents functional units, like the functionality of that. Each service packet is a self-contained with all the relevant information which is required for the service to operate. It's scalable. You can increase or decrease the size of the service, where you can add more arguments or reduce the arguments. It's reusable. You can slightly change the argument and use this service for another functionality. Uh, uh, Also, the interfaces that would be used by the service oriented architecture as more or less standardized. You have a standard interfaces to communicate. You don't need really need to establish a session or a start request to require a data. You just need to send a request, and then you get a response back. From a consumer point of view, from the receiver point of view, this would be completely a black box. So the consumer would request a service, and he gets a service as a response back, and he acts upon the service independently of the provider. And you can and also this will enable us to combine multiple services to deliver more complex services. So a complex service can in turn have multiple services inside. By this you can handle more complex functionalities. So if you see the values of the service oriented architecture, uh, interruptibility via defined interface, where you can easily transform from a traditional communications to a service oriented architecture communication uh, with these standardized interfaces, which would enable you to do this interruptibility. uh, you, as I mentioned, you can combine multiple services, and then you can handle complex functionalities, and each service can be reused with slight changes in the arguments in the service. You can also do a separation of functionalities into different services and units. So it's, as I mentioned, the service itself is an functionality, so you can differentiate the functionalities, or you can separate the functionalities with the different services, and then you can also have a distributed functionalities among the different domains, where you can each service can give you a different meaning to each domain within the vehicle. Devanshi, we have a poll here.
Yes, I am launching the last poll here. To the audience, I request you to choose options here. What do you think future EE architecture design should focus on? Uh, 5 options again: reduce number of ECUs, less weight, cost effectiveness, Ethernet backbone, all of the above, or none of the above. 15 seconds more to go. Okay, I'm closing the poll and sharing the results on the screen. 10% think reduced number of ECUs or less weight, 6% cost effectiveness, again 6% Ethernet backbone, 78% think all of the above, and 1% none of the above. Thank you, and over to you again, Hari.
Yeah, thanks, Devanshi. Okay, okay. Uh, 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 Okay, Let's move on to the how do we define the service-based architecture. So as I mentioned, the service-oriented architecture has more or less fixed interfaces or well-defined interfaces. So they are categorized as methods, fields, and events. So these are the standard interfaces, and the interfaces can be implemented on different software components, and then you can deploy the service onto the ECUs or machines. So when you deploy them, then the consumer, the sender and provider will start communicating these service based on the nature of the service. So with this, you can also have a more reliable architecture. As I said, you would define the software or the interfaces and implementation independent of the deployable target. It can be an ECU or a virtual machine. So this way you can develop a platform independent architecture or a platform independent design. This will also increase the productive overall productivity of the development life cycle, and then easy to maintain because you just need if you are changing the nature of a service or the behavior of a service, you just need to change the argument or modify the argument, and then you can reuse the service. So in this way you can maintain them easily, and then as I said, when you cluster a lot of arguments into a service, you can achieve high quality of services where you can send one service with which can give you more information. So how is this actually handled? I will explain with a example. Okay, so if you see here, this is the traditional way of defining the communications, where you have a signal for each information that you share among the ECUs. So if you will have n number of signals to be shared to combine them to a specific functionality. So if you want to perform a functionality, you might be needing multiple signal informations coming from a specific sender or a multiple senders. So when you move on to a service based, so you might request one service, and the service can be have a different arguments where you can read all the informations which earlier you were accessing via different signals in one service, and then you can perform that functionalities quickly. Okay, so let's take one example. So the example which I have chosen is the Wi-Fi notification. So assume that one of your ECU in a vehicle is connected to Wi-Fi, and the central domain controller uh, storing that connected network information into the memory of the central domain controller for next time usage. So so for this, so the central assume that central domain controller is a consumer, and the domain controller which is connected to Wi-Fi is a provider, and the central domain controller is now requesting a specific service to know the Wi-Fi status and Wi-Fi notification to know what exactly to which Wi-Fi is this domain controller connected. And for these functionalities, we might need all these information. You need to know the connection status, the SSID. SSID is nothing but the session ID, BSS ID, the wireless section of the network, RSSI, the received signal strength indicator to know how much what is the strength of the connected network, encryption method, channel number, to which channel is the domain controller really connected, the IP address, subnet address, router IP address, and DNS server count to know how many DNS server are available, and the DNS server IP address. So if you see the traditional way of implementing this functionality, the receiver or the central domain controller would be requesting the Wi-Fi notification to the domain controller which is connected to Wi-Fi, and the domain controller would be sending all this information individually, okay, as part of a different signals. This can be in one message, or it can be in multiple messages based on the length of the signal and length of the signal. But if you see the service oriented architecture, all these can be achieved with one single service, where the consumer, the central domain controller, would be requesting a service. It will send a get service notification, and this provider will set all these values to the service as an arguments, and will send it to the consumer, and the consumer can take all this information in one instance of communication, and then perform all the actions on this. Okay, so how is this approach helping the complexity? If you have seen this, you can actually have the complete payload in one service, where in this way you can leverage the full capacity of Ethernet, where you on Ethernet you can go up to 1500 bytes of payload. So you can take the leverage of the Ethernet by passing the huge amount of content in one transaction. So service oriented architectures helps to leverage the full capacity of Ethernet compared to the signal based design. As I said, the reusability, if you want to change this the service where you wanted to discard or notify or change the Wi-Fi settings, you can just change one of the argument and send it back and keep the service as it is. And then availability of service to any requester, so there is no preconditioning. Any receiver which is connected to the the provider on a specific VLAN can request a service. Easy to maintain. As I said, you can add remove arguments without changing the interface. You can acquire data in more structured way. In the signal base, you receive them as independent signals, and then you need to structure them to get a meaningful information. But in a service-oriented architecture, service-oriented design, you get the payload in a well-structured manner, and you can process them as it is. And as I said, it's a scalable, so you can increase or decrease the arguments, or you can add a complex service where a service itself can have multiple services inside. Okay, so with these service-oriented architectures, as you've seen, we are introducing more complex functionalities into the vehicle, which means more signals and Ethernet being a backbone, and this also comes with a pinch of salt, which is uh, um, safety. Okay, so your car is now more vulnerable to the cybersecurity attacks. So the architecture should also consider the security while defining the architecture when we are moving from traditional one to more complex Ethernet base. So this safety and security should also be part of the architecture during the development phase. So um, I have listed out few security levels that you can introduce in the architecture. It need not be everything. You can have multi-level security, which will uh, uh, help your car or your network to be more secure. Okay, so you can have security at an individual ECU level, at in-vehicle networking level, at architecture level, and then at a connected vehicle level, and then and also you can have a system which can detect the anomalies, and then flag flag the errors via DTCs. Okay, so you can have a different level of security. So at level 1, you can have a restricted access to the network, which means every node connected onto the Ethernet, the domain controller or ECU connected to Ethernet may not have access to the Wi-Fi or Bluetooth or cellular. So you can have a restricted network where a central gateway or a central domain controller would act as a firewall with the within the architecture, and can give restricted access to particular VLANs on the network to the nodes connected to the Ethernet. And the other way where you can restrict the access is the diagnostic communications from the external tester to the ECU via central gateway. You can have a dedicated VLAN, and then you can set a particular tag to that VLAN where this tag is enabled to a specific ECU on the network as a front end to the external tester. All the communication between the external tester would via the central gateways would be to a specific node in the vehicle, and from there you can broadcast these diagnostic information within the vehicle. But for external tester, only this ECU or this node would be visible always, because these are these are connected via restricted access network. And the other level of security that you can introduce in the architecture at a message level or a payload level is secured onboard communication. So SecOC will help you to secure a particular payload uh, with a set process, and then the sender and receiver will do a sequence of actions to validate the payload and check the whether the payload is coming from uh, from a sender who is authenticated or not. Okay, so in this secured onboard communication, this SecOC, you have a secured IPDU which would contain the original message along with the freshness value and the MAC address. So the freshness value is as an incremented value by the receiver. So the receiver first generates a freshness value, sends that freshness value to the sender. The sender would use this freshness value for the MAC address generation, MAC calculation, and counter freshness counter calculation, and then along with the payload, it will insert the MAC address, the truncated MAC address, and the freshness value, and send it back to the request the receiver who is supposed to receive the authenticated payload. On the receiver side, the receiver will first cross-check the MAC and the truncated MAC and truncated freshness value again as the freshness value which it has initially generated and sent for the truncated MAC generation. Once the validation passes, it will read the payload, authenticated payload. If the validation fails, then it will discard the payload, assuming that this is not sent by a trusted sender. So for this mechanism to work seamlessly, you also need some security keys. You can have multiple security key, primary key, secondary key, which can be pre-flashed onto the ECUs, or you can set them during runtime on the ECUs, and this security key would be also used for the MAC generation. So the MAC would play the crucial role in authenticating the overall payload and validating the sender. Okay, so in this way you can have a level of security on the message. Then you can also apply security or the policies on the data usage. So you can define data usage policies to limit the exposure. So where a sender and receiver are restricted to a particular VLAN and uses a specific uses a service specific node to implement policies in the application. Uh, and as I mentioned earlier, you can have restricted functionalities like you can only receive the diagnostic messages when the vehicle is in a specific state, when the vehicle speed is less than 5 kilometers, or when the driver door is open. You can have different level of policies applied, and then you can restrict the usage of data. You can also have a restriction where you will not allow massive steering or braking or acceleration changes when the vehicle is in certain vehicle state, or you will allow for these to be happen when vehicle is in a particular state, maybe in a crash indication or a driver request in a sports mode. Okay. And then use more than one sensor to determine the way if the vehicle is not moving. So not just relying on a specific value. For this one example, not relying only on a speed from a wheel sensor. You can also have multiple sensors, and you can cross check the value and then only use that data for your vehicle functionality. So with this, you can have the challenges which you have. You can have with this level of security. The level 3 security is high application dependent. So you need to have more checks to be performed before taking up any action, and also all the side effects while introducing any check should be considered well in the initial phase of architecture development. And the last level of security which you can have in your architecture is how do you handle the detection of anomalies, and then how do you flag these the anomalies, and then how do you defend them. The uh, anomalies are specifically a deviation to a specific communication metric. For example, if you are receiving a cyclic a specific cyclic message more often than required, then the receiver may flag this as an anomaly, saying that the sender is not a trusted one because you are receiving this message more frequently than expected. Uh, so you can have a different detection policies on these on the sender side and the receiver side, both sides, to detect the connecting pair, whether they are trusted ones or not. And when you identify uh, any such untrusted communication, you can immediately flag them. Maybe you can report and start the mitigation program mitigation functionality. So you can flag a DTC, or you may also uh, have a indication to the driver saying that this particular issue or this particular functionality has been not working as expected. Okay. And so you can for example, you can if you think that the infotainment is hacked, and you're seeing some random messages from infotainment, you can block the messages from infotainment, or you can also block a specific node on a particular VLAN, or also you can block messages from a particular sender on a particular VLAN as well. And then you can also have a backup reconfiguration program where you can reset the ECU or reconfigure a particular functionality, and then bring it back to the normal. Okay. So on a conclusion note, uh, I have, in the interest of time, I have already touched on all these summary points in my previous slides. How the service-oriented architecture enables the flexibility and open and dynamic distributed systems. It also simplifies the functional units, which can be contributed to create multiple complex functions. So you can have a distributed for services. Service interface is a main. You have a standard interfaces which can be used for these services. You can have a multiple security levels introduced in your architecture. Need not be a what I have specified. You can also have a different level of security introduced, but uh, suggestion is to consider the level of security that you would be introducing in your vehicle at much earlier phase, and then incorporate them in your architecture developments. So overall, we believe that the service-oriented architecture methods will enable designing a scalable architecture for tomorrow's technologies and use cases, of course, with considering the security. Uh, yep, I'm done. Devanshi, we were open for questions.
I have informed the attendees that in the interest of time that we will take all the questions from here offline. Please do put if any questions more on the questions panel attendees, and I shall collate it and send it across to the speakers for the possible responses and get back to you all. So I think we are good to take all the questions offline. Right, Kishore, Hari?
That
Yeah,
should be okay.
yeah.
Yeah. Okay. So as a closing note, on behalf of NASCOM ER&D, I would like to thank Kishore and Hari Kiran for an insightful session. Thank you all attendees for joining in for today, and we look forward for your participation in the upcoming events and webinar series. So
Thank you.
as always, we would love to hear your feedback, audience, and hence requesting each of you to kindly share across the filled survey forms within 24 hours of the follow-up emails on your registered email IDs here. Thank you, Kishore, Hari, once again, and the attendees. Stay safe and alert, and keep your families and friends also safe. We will look forward for the next session as well.
Yeah.
Attendees, thank you so much.
Thank you. Thank you, Devanshi, and thank you, NASCOM, for giving us the opportunity to present and share our experience in this area. And thank you, participants, for attending this session. Keep yourself safe.
Thank you. Bye-bye.
Yeah, thank you. Bye.